There are many challenges and concerns when you're working with databases via JDBC. I've listed many of them here. This can be a daunting list for a Java developer who's not an expert in databases. If you're working in an environment that's using an enterprise database, you've probably got people on your team who have a lot more knowledge about many of these issues than you do or can hope to learn in a short time. For this reason, the best place to deal with many of these issues is on the database server itself. If you've got database administrators or DBAs and SQL developers, your job will get a lot easier. They will tackle many of these issues with database server features like indices, constraints, triggers, and stored procedures. They'll puzzle over explain plans for performance issues and write all kinds of monitoring and logging code. They're often experts in turning queries, so who better to write your queries than this impressive group of people? Even if you don't have access to this talent pool, you should consider addressing at least some of the problems listed on this slide with server solutions. This is often done with functions and routines written in SQL or transactional or procedural languages that integrate easily with SQL. These items are often called stored procedures as a category, though there are two separate database artifacts, the procedure and the function. Stored procedures are a way to encapsulate complex SQL logic and data manipulation into reusable modules that can be called from within the database. They can help to improve application performance, modularity, and security. They're precompiled queries or segments of code that are stored as just another database object. Your JDBC code can be simplified quite a bit if you're able to take advantage of stored procedures. A stored procedure can also be written externally in Java, Python, or C and stored with a wrapping procedure in the database, which means that code will run on the server. I won't be covering this last bit, but you should know that some databases, like SQLite and H2, only support these external types of stored procedures. I'll be covering functions in a later video and will explain the differences later. It's very common in an enterprise environment to protect access to the database and to restrict what your clients are allowed to do. Because of this, you might find that most of your JDBC work will be done with requests to stored procedures. Java supports the execution and retrieval of results from these code segments with a special kind of statement named the callable statement. Like a prepared statement, this first takes a parameterized string when you get an instance. The object reference will already be compiled in the database server. Like a method in Java, you pass in data with parameters and you may or may not get data back. Depending on your database, the data coming back might be a result returned from a function, or it could be returned with declared output parameters. Some databases also support a hybrid parameter and input-output parameter, which lets you pass data which may be modified by the procedure and pass back. I'll explain these parameters a bit more later as we explore how to use the callable statement. First, we need access to one. I've included a DDL script in the resources folder of this lecture named addalbumsongs.sql. You should download that script and put it somewhere on your local file system where you can access it easily. Next, open MySQL Workbench to your development connection. In this case, you'll select the second SQL editor icon, which will prompt you to open an SQL script. Find the script you downloaded and select it and hit the Open button. That should load this script in your Edit panel. Now, you just want to execute this script, so the first lightning bolt icon there will do it. If you refresh the schema panel, you should confirm that you see this new procedure named addAlbum under the Stored Procedures listing. Click on that and select the wrench or tool icon there. This will load up the Stored Procedures code. I won't get into this code too much, but what you do need to know is what the parameters are to this routine. There's 3 of them: an artist name, a text field, an album name, also text, and the last is songs, a JSON type. MySQL stored procedures don't currently support arrays, but they do support JSON objects, which can include arrays. In this case, this is a way to pass an array of text, which will be an array of song titles to this stored procedure. This code will add the artist if it's not in the database, or get the artist ID if it is. It'll then add the album if it's not there, then inserts all the songs associated with that album, looping through the songs parameter using MySQL JSON functions. All three of these parameters are input parameters. How do I know? If you don't see one of the keywords, in, out, or in out, then the parameter is by default an input parameter, so the keyword in is implied. This is important to know for the callable statement. Before we get back to IntelliJ, let's make sure we've removed any Bob Dylan records in the music dataset. I'll open another SQL edit panel and type in a delete statement. So delete from music.artists where artist name equals Bob Dylan with his name in single quotes. In this case, I'm using all lowercase for the SQL keywords as I type it in, since this is just an ad hoc query. I told you to use uppercase for SQL keywords, and I know I haven't always been consistent and will sometimes forget to do it myself. There's a Beautify Reformat option in this SQL edit panel, and that's the little broom icon. I'll click that. I don't always like the way it reformats it, but it does change the keywords to be uppercase. Sometimes I just want my query to be on a single line and quickly execute it, so I may not beautify it. But if I'm using the code in a JDBC statement or a stored procedure, I do try to be more disciplined at any rate. I'll execute that so that the music database won't have any data for Bob Dylan when we first execute this procedure. You'll hopefully remember that we added cascade deletes on the albums and songs, so this single statement will clean up all that related data. Switching back to IntelliJ, I'll reopen the prepared statement project again. I'll create a new class in the dev LPA package, which I'll call music callable statement. And it'll have a main method. I'll start by setting up a couple of constants. These constants just represent the column index of the data in the CSV file. So the artist name is in the first column, so artist column equals 0. The album's in the next column, index 1. The song title's in column 4, so index 3 here. I'm not going to use track number in this case. The stored procedure will assign the track number in order based on the order of the songs. I'll be setting this up as a map, keyed by string, with a nested map as the value. I'll set up my map variable. Its value is a map, keyed by string, with a value of string. I'll call this albums and initialize it to null. I'll show you another way to read the song data from the new albums.csv. This time, I'll use the lines method, which returns a stream of string. All of this is a good review of streams, and it'll actually make passing the data to the stored procedure a bit easier. Just a reminder that when you call files.lines, you should do it in a try with resources so the stream is automatically closed. I'll do that here. Inside the try clause, I'll set up a variable simply called lines. I'll call files.lines with a path to the new albums.csv file in the project folder. That returns a stream of strings. I've got an error on the lines method because I need to include a catch clause, so I'll hover over that error and pick Add Catch Clause. Inside the try block, I'll set up the stream pipeline. So the first thing I'll do is split each line by the comma. I do this with the map operation and a lambda that splits the string. This means my stream goes from a stream of strings to a stream of arrays of strings. I'll collect this data into a map with collectors.groupingby. The first level is grouped by the artist. Now, my file only has Bob Dylan as an artist, but let's just say we didn't know that. The first level of the mapping is the artist. The next grouping is the album. I'll call collectors.groupingby again and pass the value in the album column. Then I need to get at the song column to collect the song titles. I'll do this with mapping, returning only the song title. Next, I'll use collectors.joining, which ultimately uses string joiner. The goal here is to make this look like a JSON array, which really just looks like a printed array. The delimiter is a comma, but I also need to wrap each song title in double quotes, so I escaped it with a backslash on either side of the comma. and that'll be wrapped in square brackets, which will be my prefix and suffix elements. I need the starting double quote as well for the prefix. The same goes for the closing double quote and closing bracket. I'll print this out so you can see the result. I'll loop through the albums. The key was the artist name and the value is that artist's albums. Next, I'll loop through the nested maps data. The key is the album name and the value is the string value, the array of songs. I'll print that out. I'll run this. And you can see this file has 2 albums, and I've got all the songs in a single comma delimited string, each song title enclosed in double quotes. Next, I'll go over to the main class from a previous video, and I basically want to copy the entire main method. And I'll paste that at the end of the main method in the main class. I'll remove the code that sets the continue batch on error flag, so that first pasted try catch block. I don't need to worry about this now because my stored procedure will handle the entire transaction. I'll also remove the call to the add data from file method there. I'll keep the select statement there and the prepared statement that uses that just to confirm that data does really get added. Here is a case where I miss making an SQL keyword uppercase, so I'll change the case of the where clause in this statement. I've got a compiler error on print records because that method's on the main class. I'll open the main class and change the modifier from private to public on that method. Now, back to the music callable statement class, I can just prefix the method print records with the class name main. Okay, so now that this code compiles, I'll add some code at the start of this try block before my first SQL statement there. I'll be executing the stored procedure using a callable statement. You get a callable statement much in the same way as a prepared statement, but you invoke prepare call. And you pass that an SQL string. To execute a procedure in the database, you usually use the keyword call followed by the procedure name. Again, I'll prefix that with the schema name. And like a prepared statement, I use a question mark for parameters. In this case, the stored procedure has 3 parameters, so I'll put 3 question marks there. A callable statement also gets parsed and compiled, which means I can reuse this statement efficiently. Next, I'll use my albums map, looping through the keys and values with a for each method. The key is the artist and the value is the nested map. I'll again use for each, and now the key is the album and the value is the songs array, a string, a JSON array. I have to include a try catch in this lambda expression. Like a prepared statement, I set the values for the placeholders, so first the artist, then the album, and next is the JSON, which is really just a string ultimately. I can run this using the execute method. This stored procedure doesn't return any data back. If I get an exception, I'll print the more specific vendor error code and the message. And that's all I need. Before I run this, I have to set up my system environment variables as usual. I know for the challenge video, I used environment variable names that didn't include the underscores. I hope that didn't confuse you. It doesn't really matter what the variable names really are, but I'll switch back here and continue with these names moving forward. That's done in the run configuration. Once I have that set up, I'll run this code. Here, you can see the data in the album view, which confirms that I successfully added the artist, the 2 albums, and all the related songs in that CSV file with just 2 method calls to code stored in the database. Some database vendors do support arrays, but MySQL is not one of them, so that's why I used the JSON workaround. As I've said, it's important to understand what features your RDMBS supports. If you're using callable statements, it's less likely you're concerned about being database agnostic with your JDBC code. So in this instance, I showed you an example of a stored procedure that took 3 input parameters and didn't return any data back. In the next video, I'll cover in and out parameters and how to use them. Okay, let's move on, and I'll see you in that next video.